Hello everyone, my name is Lai. I'm Esri APAC BD Manager. I'm your host for today's webinar along with my colleague, Jeff Allen, an in-country colleague from Esri US and Asia Pacific offices. Jeff is Esri Global Pipeline Practice Lead. On behalf of Esri, welcome to our webinar on a new era begins in pipeline network data management. Today, we will introduce ArcGIS pipeline referencing and ArcGIS utility network tools in utility and pipeline data model with new exciting functionalities to help you in managing and analyzing pipelines seamlessly up and down your energy supply network. Next slide, please. Now I would like to invite Jeff to share with us the new excitement in linear reference and connected pipeline network. Jeff, over to you.
Excellent. Thank you, Lai. And thanks everybody for joining us this afternoon. This is our first webinar for the APAC region in the APAC time zone. Hopefully this is something we're going to continue on in the past. This is a webinar that we've been doing kind of around the globe. We do it here in the US. We've done one in the Europe region as well. And it's really an interesting topic, and we've got a lot of interest from pipeline operators all over the supply chain around this topic. And basically what's driving a lot of the interest around the world is that a lot of our customers are trying to build more and more detailed information models, more details about the system of record of those pipeline facilities that are out in the field. There's a lot of drivers for this, obviously regulatory being one of them, but really workflow efficiencies. As the GIS becomes that single source of the truth within the organization, and we start to elevate the GIS as sort of a tier one system within inside organizations and start to integrate with other systems, we need a more complete picture of what's out in the field. We see this even more now today, where we have remote staff working all over the world on pipeline projects, being able to see a detailed inventory of what's in the field without having to make travel and go to those locations is more important than it ever has been. And so that's why we at Esri have been kind of working really diligently on this problem. And really the problem we're trying to solve is, how do we model this entire supply chain in a single enterprise GIS? And when we say the supply chain, we really mean the upstream, the midstream, and the downstream segments, both hazardous liquid and a natural gas transmission and distribution and gathering. The simple story is that pipe is pipe, whether it's offshore gathering or a large diameter transmission pipe or small pipes in the city streets. We should be able to model pipe the same way. However, we all know that if you've been in the industry long enough, that there are different requirements in each of these segments. And bringing this information together in one seamless way is really a difficult technical challenge, as well as an operational challenge as well. Oftentimes we'll find organizations have data in multiple GIS systems that aren't talking to each other, maybe in multiple systems outside of GIS, like stored away in CAD drawings or LiDAR image point cloud files. And really our challenge is, how do we pull this all together and put it into one single enterprise geodatabase so that we can run analytics and optimize workflows around that. So that really comes to the crux to what the webinar is today, is showing you how we're doing that in the Esri Enterprise Geodatabase. And so be able to model that pipeline facility from the wellhead to the meter tip and everything in between. We're really applying two separate software technologies on top of that single enterprise geodatabase. And those two software technologies are ArcGIS pipeline referencing, which allows us to do the linear referencing portion of the pipelines, as well as the utility network, which brings in some really interesting new capabilities around business rules on connectivity, containment, and diagrams. And really what we're doing here is pulling the best of both worlds into both of these applications to manage pipe data. So really, when we look at the overall solution, the kind of new things we're bringing to the table beyond the linear referencing is this idea of the utility network, right? This underpins the entire solution and brings us some interesting new capabilities. Obviously, mapping, being Esri, that is the cornerstone of what we do, but also alternative views of that data. So I can take that map data and then put it onto, say, an operational diagram or a schematic and represent that mapping information in new and interesting ways to my field staff. We also introduced the concept of component or container views. So I can basically build a GIS within a GIS. So again, as I start to build out these really detailed systems of record, putting all that data onto the map is very challenging. So I can build now buckets or containers and build up components that get really down into the details of what's inside of these facilities. Obviously, along with the mapping capabilities is to be able to answer questions about those facilities. Then we start turning to advanced analytics. How can I trace my system? How can I understand pressure and flow? These are topics that we've been asked about for years in linear referencing. The utility network really now starts to turn that on and bring that alive. Being able to look at both historic and planned facilities, right? So I can start putting my details of my new assets into the GIS during that design phase. We've got a lot of interesting workflows now around moving GIS from planning to design, and then from design back to operations. And these historic and planned views allow us to do that. And then the last topic that's quite interesting is the ability to visualize all this data in 3 dimensions. So taking these 2D maps and adding the Z elevation to the components, and then be able to view this data in a 3-dimensional or a web scene is something that we can now do with this new capability. One of the important things about both ArcGIS pipeline referencing and the utility network is we now see our software moving away from the traditional client-server architecture into a more of a web services architecture. When we move to web services, we're publishing the data from the server, which you're probably familiar with web mapping applications. We're actually consuming those web services in the editing workflows. So now I can not only edit from my, say, Pro desktop, but I can also do those same edits for a web application or a connected mobile device. This also brings in more interesting capabilities from the server, because that server now contains a rule base that has business rules built into it and is basically protecting that underlying data. So regardless of whether data edits are being made from, regardless of what platform they're coming in from, all those edits need to pass our rule-based validation before they can enter the system of record and be viewable by the rest of the organization. So as we start using these tools and so we move in this direction, you'll see more and more tools from Esri come out with this web services pattern. This system of systems is really the new generation of WebGIS architecture moving forward. So when we start thinking about the utility network, we have a domain where we start layering information into the pipeline data model. And so we have a number of domains, and what I'm going to be focusing on here is what we call the gas or pipeline domain network. This allows me to put in features into my network, devices, lines, and pipelines, and connect them together. These then form the basis of my entire pipeline system. So these are the intelligent devices that I now build into the rule base. And so we don't put you into a specific pipeline data model. So we support the industry data models, and I'll talk about that in a second. But these are going to be the core feature classes and core configurations that we'll use to enable this new utility network information model within the ArcGIS platform. Sitting right next to the utility network information model is the ArcGIS pipeline referencing information model. These would be the equivalent core tables and feature classes that we would add to the Geodatabase to enable linear referencing on top of those pipes. So the pipes would go into utility network, and then we would add on top of that linear referencing capability to those pipes. So if you've looked at this APR model in the past, this slide is going to be very familiar to you. But what you might have not have seen before is really when I just transitioned the slide there, is that in the go forward model, instead of having that traditional geometric center line that underpins my pipes, the utility network pipe feature class is the center line for my linear referencing. This will become more obvious when I do the demo, but basically we lay down all our pipes, we connect them together, and then we drop linear referencing on top of those pipes to enable the full capabilities of the platform. So if you wanted to see this in action, these two information models are actually embedded into a larger pipeline data model. And from Esri, we have the utility and pipeline data model that's freely downloadable for any of our customers. This has got the utility network core objects, it's got the core pipeline referencing objects in it, as well as a lot of other information tables and feature classes around pipeline operations. Things like inline inspection, integrity compliance, asset inspections. We've basically handed off a template or starting point for which you can build a larger pipeline referencing or pipeline information model. And so when you download UPDM 2018 or 2019, you'll find inside of that the pipeline referencing tables, the utility network tables, and now we're just about to release UPDM 2020, and it's scheduled for August 11th. And that'll have more enhancements to the model, more feature classes, more attribute rules associated with managing pipeline data. Now, as well as being able to offer to the industry a template data model, UPDM, we also work with industry models as well, our industry organizations. I'm part of the PODS Open Pipeline Data Standard, and we've taken the core ArcGIS pipeline referencing tables and we've now embedded them into PODS. We also have a working group now to embed the utility network functionality into PODS as well. So those are two industry standards that you can use with these two tools I'm going to show you today. But also doesn't prevent you from taking those core tables and implementing them to any schema. So if you already have a pipeline data model you're using, you can embed our core information model and turn on the networking and turn on the linear referencing capabilities inside your existing enterprise geodatabase. So let's talk about the rule base. So what are these? So basically what this does is ensures that the data that we're adding to the system follows not only geospatial rules, like things are edge connected together, and topology rules, but really business rules as well. So in the rule base, what I'm able to say is, hey, when I'm connecting a flange, a metal flange, for example, to a pipeline, that pipeline also needs to be of metal. Or if I'm connecting two pipes of two different diameters, I need some type of reducer or fitting in between. So the rules kind of fall down into a couple different categories. We've got junction, how two devices or two junctions connect together. Junctions to edges, how these devices or junctions connect to the pipes. And then the edge junction edge connectivity, right? How do two pipes connect together? What needs to be in between? And then containment rules. When we start building up these objects and assemblies, what can be contained with other objects? When you download the UPDM model, it comes with about 3,000 rules already built into the model, and then an endless combination of possibilities to add your own rules or modify rules that come on the template. So this is really critical for keeping the data quality of that information that's going into the utility network. No longer can somebody just open it up like an old geometric network and make a change and break it, right? It has to go through this validation before it enters the utility network basis. I talked a little about containers. This is an example of a pipeline container that I built for a pump station. So here, typically, maybe I had just a point or I had a polygon on the map that represented this pump station. Now I can actually enter into that polygon or enter into that pump station and start layering inside of it more and more details. I can show the pumps, the bypass piping, and even the assemblies themselves can be containers. So I can have containers within inside of containers. So think of these as kind of mini GISs that are inside of the larger GIS, and it allows me to stack these components. So I'm not trying to look at 10,000 objects on the map. I'm looking at the details as I traverse down through the stack. The other really important part of the solution is something we call terminals. So in the past, what we've done is when we had a device along the pipeline, we simply place that point or those lines into the map. And as long as they were topologically connected together, we could see information flowing through them. But now we've actually given these terminals or these devices intelligence. And so instead of just dropping a single point, I can now specify how this object interacts with the pipes on either side. So a great example of this would be a check valve, right? So a check valve, depending on how that check valve is installed, may allow product to flow one way or the other. Just a single point's not going to give me that intelligence. Other examples would be things like isolation valves or pumps or compressors. Those would all have terminals, and those would all be defined. So a pump would have a low pressure and a high pressure side. And when I add those types of devices to the network, I can start looking at things like flow and pressure within the system. And I'm modeling those things based on the actual devices. I'm not having to go in and just fill out attributes of my pipe. These devices are actually controlling that logic within the model. So here's a couple examples of what those terminal configurations might look like. For example, on regulators or reducing pressure valves, I might have a high pressure going to a low pressure. Sometimes I have generic flow, so the product can flow in and out. So like a wellhead source flange has an inflow and an outflow to it. Some things like isolation valves can flow bidirectionally, right? So it has two generic ports that allow me to define which way the product flows, or pressure increasing terminals like compressors and pumps going from low pressure to high pressure. That doesn't really stop at the product flow as well. We were using these devices to actually model and map the CP, or the cathodic protection, along these pipelines. So not only can I see all the devices that are electrically connected together by pressure, I can see all the devices that are electrically connected together. So I can connect my rectifiers, my anodes, my test leads, my insulated flanges, and be able to look at my system from a CP perspective as well as a pressure perspective. Now, the interesting thing with these components is that once I've set these devices along the line and I've wired them into the pipeline, I can then now see all the things downstream of these devices that are connected together, right? So we call these things subnetworks, and this is a great example. One of the hierarchies in our system we defined as a pressure zone. So basically what I do is that once I wire in, say, a pump or a compressor, I can then tell the system, hey, show me everything downstream of this point that sees the same pressure. Which in turn, I can do interesting things like, as I traverse a system, show me the minimum maximum MAOP value for all that equipment in these pressure zones. These are queries we've been able to do in pipeline in the past. However, we've had to maintain these as individual data elements, whether they're ranged events or business attributes. And anytime there's a reconfiguration of the system, we have to remember to go change these business values. Here, all I have to do is add a new device, and these subnetworks automatically update based on that, on those summaries of what they're connected to. And this kind of leads into those more advanced analytics, right? So what that really is doing in the background is it's running a trace. It's running a trace on the connectivity model that's automatically being built in the back end of the system. And this trace now is the entry point from a lot of different analytics that we can run along the system. I talked about the CP traces, but I can do like isolation zones, I can do pressure systems, I can do business systems between meters. source and sink. There's a lot of different analytics that we could run that start as a trace, collect up a series of features, and then pass those features into the next stage of the process. And then finally, network diagrams, right? I talked about this at the beginning. This is an alternative. I kind of refer to these as an alternative view of my maps, right? Everybody can see these objects on a map, but when I'm really looking at a network and looking at the devices and how pressure and flow is affected, oftentimes the map is not really my best mechanism for that. So we now have the ability to take the map data and automatically create diagrams for that. And those diagrams are also stored in the Geodatabase. They can be shared out through the system of engagement. They're live linked to the map. So if I see an object in my diagram and I want to see where it is geographically, I can move seamlessly between those two environments. And I'll show you an example of these diagrams when we get to the data set. So with that, I'll leave off the slides. Just a reminder, if anybody has any questions, please fill them in, and we'll be answering questions when I come back from the live demo. But one of the things I like to do when I do these demonstrations is not just show the same demo data set that we always show for our US operators. So for this particular webinar, what we did is we went ahead and built out a sample pipeline data set for the APAC region. So this is completely made up. This isn't any one operator's data anywhere in the world. This is the Jeff pipeline that I created, but I created it with a couple of concepts that allowed me to demonstrate some of the different utility network cadences. So obviously I have a map. And I have assets on that map. And if I zoom in a little closer here, we'll start, and you can see what I've attempted to do here is to model some offshore pipelines, maybe an offshore transmission line, onshore to some storage facilities, and onshore transmission lines as well. And I'll kind of take you through each of those locations. What I want to do is really start with these offshore facilities, because I think this is a really interesting use case for the combination of the linear referencing and the ArcGIS pipeline referencing and the utility network, because we've often tried to put this pipe into a linear referencing model, but there's lots of, and you can kind of just see it here on the screen, there's lots of use cases around connectivity and how these objects are sort of wired together in the field. So you can see I've got some wells here with some that are connecting to some manifolds. Those manifolds then take those pipe and move it off to a gathering position. So we've got some more manifolds coming down here to the collection point, and then we gather up all that product and move it through the transmission system back on shore. But what I've done here is, and this will kind of show the first capability is, what if I wanted to see what was connected to one of these offshore wells? Well, because I've got the connectivity model behind the scene, I can simply create a starting point for my trace, and I'll just go ahead and zoom in here. Let's start on one of these offshore wells, and I'll just click on that as my starting point. Let me get rid of these couplings. So I'll just go ahead and add this offshore well. Now, at first glance, it looks like that this is just a point sitting out in space, but I've actually used a lot of the utility network to go ahead and wire this point into the network. And I can demonstrate that if I just run a simple connected trace here. And this will show me everything that's connected to that particular well. So you can see it's gone ahead and selected some of the lines in this field, brought it into this manifold. Something's happening inside this manifold to take it down to that offshore gathering facility. And so if I want to take a look at how I was able to do this, those couplings really come into play. So I'm going to zoom back into this location here. And you can see I've added a couple of couplings to the end of these pipelines. And if I look at my associations, I've gone ahead and associated this coupling with this wellhead assembly, right? So that's how that is starting that process. It comes down to this manifold, and inside this manifold, what I've done here is I've actually created this as a container. So if I was to go ahead and enter this manifold as a container, what this will do is this will expose more details inside of this component. Go ahead and it'll open up the container for me, and inside of this container, I happen to have all the different couplings that are associated with this particular manifold. And again, if I turn on the associations, I can see that I have this coupling coming in from that well tied over to here, which then continue that trace on down the line to that offshore facility. And then again, that same cadence holds true if I continue to walk down the line. I come onto the FPSO, come into that facility. Again, all those individual manifolds are then connected to their appropriate meter on the facility, then back out to a pump, and that pump then pushes that product into my offshore transmission line to bring that product on shore. So again, no linear referencing yet. These are all just connected models and devices. The interesting part of this, if I want to add some more details, is I can bring other design information in the back. So all these pumps and all these facilities have intelligence. Let me just exit the container here. But it doesn't prevent me from bringing in more details of the model behind the scenes. So here what I've done is just gone ahead and bring in a CAD model of those supporting structures. And now you can see that offshore device, that offshore ship that's capturing all this information and pushing it on shore. We can see more information about the manifolds and some of the other subsea information as well. And if I make my way down to the device where I connect to my transmission system, I then transition into this manifold and into my offshore transmission system. So at this point, I have linear referencing information that I want to add to these pipes. So these pipes have begin and end measures to them potentially, or pipeline length. But in this case, maybe I have inline inspection data or rover data that I want to associate with these lines. So now I can go ahead and turn on my linear referencing system. And so what we've done for that is just simply take those pipe center lines and add in routes and measures on top of them, right? So now what I have in my transmission system is a route measurement system that now sits on top of that pipe. And if we zoom out further and come down here to the onshore system, let me just go ahead and turn some imagery on. You can see I've got routes and measures all on that transition system, all the way to the onshore facility, into my onshore meter system. And then you can see I entered this plant. So here what I want to show you is, not only do I have those offshore facilities, but I can switch again coming off the linear referencing system into my, what I would call inside the fence piping. And in this case, I'm coming off that transmission line into a pumping facility that's moving that product in and out of these tanks. So each line coming into the tank farm has a check valve that's again connected to these tank objects. I can see those connectivities there and turning that product right back around. And again, from that connectivity perspective, if I run that connected trace that I ran initially, not only did we come in that off of that offshore platform, but came into that transmission line. Oops, I deleted that starting point. Let me just go back and set that again. So I'll just set that starting point again. So now when I run that trace and I go back to that onshore facility, you can see that trace has come all the way in from my onshore line, all the way into those pumping facilities, discovered all those devices, and then in and out of my tanks, back out to my outgoing pumping facility, and then again back onto my transmission system. So I can now discover from end to end everything from my offshore well all the way through my manifolds to my facilities, and then down to that to my onshore connected pipeline, and eventually taking that product into the refining facility on the other end. So now let me show you a little bit of that transmission facility. So coming out of that storage facility and then back into the transmission system, I'm back onto that linear referencing network. And I actually want to show you how I go ahead and set this. So I'll go up here to this other end of the line because I've set my linear referencing system up into this mainline valve, and I have just pipe here, but no linear referencing yet on this part of the system. So remember, the pipes are in my utility network, right? So if I was to select this object, you would see that that's part of the pipeline transmission pipeline feature. This is in the utility network. And remember what I said in the PowerPoint, that is going to become the center line of my pipe. And the only thing I need to do for that is on that pipe record itself, I've gone ahead and pre-filled in the begin and end measure for this section of pipe. So that's my begin measure, my end measure in meters for this particular pipe segment. So to add linear referencing to this line, I'm going to now switch over to my linear location referencing toolbar. I'm going to select the create tool. I've already selected the center line, which is that piece of pipe, so one selected here. I'm going to select what network to put that within. I'm going to put it in my engineering network. I'm going to make that network active today. I'll give it a line name and a route name. And you can see it's automatically picked up the end measure from that underlying pipe in the utility network. So this linear referencing system is going to go from 0 to 6036. And if I run that, we should get a new route on top of that line. And if I turn on the linear referencing system, let me just clear that selection set. I now have a linear referencing system sitting on top of that pipe. So there's all my measures. If I wanted to add any data like ILI or other facilities or inspections by measure along this line, I can now do that, and it now participates right on top of the connected model. So I can discover those objects, and I can actually dynamically segment the two systems together. So if I had a linear event for, say, my pressure range, and I want to intersect that with a pipe that's sitting down the utility network, I can run a simple dynamic segmentation engine to do that. Or the flip side, if I wanted to trace this network and find all the pipe, and then find all the associated linear components with that, they're all connected in the model too. So I can go from the utility network trace side to discover the linear referencing objects, or the linear referencing objects down onto the underlying pipe within inside of it. So this is now very dynamic. I can go from basically, I can flip back and forth between stationed and non-stationed pipe and be fully connected from my offshore gathering, offshore transmission, onshore facility pipe, and onshore transmission. Now, you can see what I did here is I've actually used the pipe length to do the initial calibration of this new segment. And so one of the nice things about ArcGIS pipeline referencing is that we only really need 2 calibration points to get started. I have one here at 0, and it will automatically add another calibration point for me at the end of the line. So there's that length measure there. But obviously for more detailed pipe modeling, I would typically have additional calibration points along this line. And a calibration point is simply a known location on the map that has a known location and a known measure, okay? And I can add as many of those additional calibration points as I want. And every time I add a calibration point, the linear interpolation of that point or linear interpolation of the objects along that line is going to change. So let's go ahead and add a calibration point at this bend here. So you can see from the initial measurement system, this point has been calibrated to be 1173 from the start. And what I'm going to do is I'm going to go ahead and put in the true measure of this location. So let's say I have an as-built drawing that tells me that the measure of this bend is 1190, right? So it's a little bit longer than the 2D length. And when I run this, if you keep watch of those measures, you'll see everything been readjusted based on that new linear interpolation. So now we've basically locked in 1 plus 190 to that bend, and you can see the underlying value there. If I just turn off that label really quickly, that's now the measure of that point in that vertice is 190, right? So if I had a mainline valve like here, once I add a calibration point to that mainline valve, then I have forever locked location and the measure of that valve together, right? So that allows me to tie those two systems together. And then again, I can go in and add any number of calibration points to the line to get that fully calibrated. And typically what we see in most implementations is that we see every kind of major bend from the as-built survey, the horizontal and vertical bends along that line as calibration points. But you can add as many calibration points as you need to really tie the linear referencing system to the underlying utility network pipes. And then at this point, it's simply, I would just move on to start adding and loading in linear events on top of these lines. So maybe I have an ILI data set that's measured in odometer readings. I could then calibrate those odometer readings to these engineering measures and then bring those points in. The important thing to realize about both ArcGIS pipeline referencing and the utility network is that every object in here is a simple feature in the Geodatabase, right? And so being a simple feature, being a point or being a line or being a polygon, I can easily share this information out with web maps and the rest of the organization. I don't have to take this data and manipulate it to be able to use this information with the rest of the Esri stack. I simply take these same web services that I'm editing here in my Pro, and I can go ahead and move them right into my web maps and my mobile applications. So kind of back to my initial demonstration of that trace, one of the interesting things I can do with that trace is find all those objects and then using some of the utility network capabilities, create a diagram for those objects. So what I did is I just simply ran a trace of this entire network, and then I created a new diagram for those selected objects. So I'll just switch over to that diagram view now. So this is that entire system from the offshore wells through all the manifolds, through that ship that's containing the product, push it out through into the into that tank farm, out of the tank farm the other side, and down that transmission line into that facility on the end. So much different view of how that looks. And you can see if I go back to my network diagram tab here, I've got all kinds of interesting diagram layouts that I can apply. Force direction, geo-positioning, smart trees. This one I happen to run as a mainline tree because I thought it really demonstrated the look and feel of what I was after for this. But as I said, all these things are connected together. So if I'm interested in seeing in particular what this inbound check valve is and where it's located, I can simply select that here from the diagram, apply that back to my map. And when I move back to my map, and if I zoom in, there's that object coming from the schematic. So tied together, oftentimes I see users having these views side by side, right? So I can have my using the side-by-side pane view, be able to see my maps in one side, my diagrams in the other, and everything that's available to me in the map from an attribution standpoint, these are the same objects, right? So I have the same business attributes that I can query and edit and maintain from the diagram view or from the map view. So one of the other requests that we've gotten is, when we get down inside of these facilities, like say down into these buildings here, oftentimes there's other information locked away in other third-party systems, whether it be LiDAR files or three-dimensional CAD drawings. There is an as-built or a BIM file for these types of facilities. Now that doesn't mean you have to load that entire BIM file into the utility networks to make it go. You can see here, I've got these flanges, a meter, a valve, and a couple of pumps. I don't really know where they are physically inside these buildings. I just laid them out here from a purely a schematic point of view, and then use the association tool to tie them together, right? So if I was to click on, if I was to modify my associations, let's say I click on this pump, I can see that pump is on the low pressure side, right? So remember, this pump has an in and an out to it. So the weld on this side is tied to my low pressure in, and my high pressure out is tied to the weld going out the other side. So that's showing kind of that connectivity model and the terminals working sort of side by side. But if I wanted to really dive inside this building, I've got another sort of demonstration here where I've kind of created that container, and I've used the 3D drawing or 3D as-built to actually build out logically, or physically inside the building where all those devices are. I can view the connectivity here, and you can see it gets quite interesting or quite hard to understand exactly what's going on because I've got a lot of vertical stack inside this building. But all these objects that are in this utility network layer have been modeled with Z elevations to them. And once I have that Z, I can take all this information inside this facility and I can throw it onto a 3D scene. So now I'm looking at that same utility network layer, ArcGIS pipeline referencing layer in a 3D scene. I can see my above ground pipe here. So I can see the launcher receiver assembly coming out of the ground. I can see my bypass piping. If I was to turn the ground off, I'd see all the underground piping in this facility, right? So I now see where that pipe goes below ground, 90s up vertically into these valve assemblies. And here I've actually got the 3D drawing of that building. So this came from a BIM file from the as-built to this file of this building. And if I peel away the roof, you can now see where all those utility network objects came from. So I literally went into my 3D scene view. I'm sorry about that. I went into my 3D scene, placed that again side by side with my 2D scene, and then just place these objects on top of the representative objects in the 3D scene. So now I've got a real digital twin that kind of shows me what that pump and what those valves look like. But I've got that utility network smarts or connectivity embedded in there as well. So now as I traverse and go through this model, I can see what it physically looks like. But if I turn this off, I can see how the objects in the utility network are laid out in 3D space. And again, these are queryable, discoverable. I can trace on these objects. I can connect them together. So that's where we're heading, right? Is to be able to not only go onto the pipeline centerline, but eventually build out these really detailed 3D models. Because when you think of tying the GIS to, say, an information management system for work orders, there's clearly work that needs to be done inside these buildings. There's clearly devices inside these buildings that contain pressure that I want to make sure I discover if I did a trace of this facility. So this now brings together linear referencing, network modeling, 3D modeling, all in one shared geodatabase, all being able to be discoverable and shared out with the rest of the organization. So with that, we've got about 10 minutes left. I'll go ahead and switch it back. And Lai, I think we'll kind of open it up to any questions from the audience.
Right. Jeff, do you have the questions from your side?
Yeah, let me pop it open.
So the first question over there posted, Jeff, is that can we get a sample data and tutorial file to get tested out? I presume the answer is yes for that.
Absolutely. That's one of the reasons I kind of built this new demo data set from scratch, is so I can share it with you guys. So my idea was to kind of put this together and continue to build on it. But I can actually take this file, this geodatabase, and export it to a file geodatabase and make it available as well.
Yep, and then some others like how do we manage the linear events such as the sections of a pipe that require refining or rust monitoring?
Sorry, what was the last part of that line?
How do we manage the linear events such as sections of a pipe that require refine or rust monitoring?
Yeah, that's really interesting. So, you know, when we think about the pipe itself, we think about a couple of different things that are actually all interacting together. You have the larger pipe segments, like where we have this similar characteristics like OD, wall thickness, grade, manufacturer. We typically put those in as pipe segments. Then we have what we call the pipe lengths, which are the individual 40-foot joints that make up those larger pieces. And then between those joints, we have the wells. And so the way that we've modeled this is we have the larger pipe segments in the utility network, and we're modeling the pipe lengths as individual ranged events on top of that pipe with those welds in between. So if I ever wanted to get back to, say, a heat number or a joint number, I can simply query that pipe segment linear event or pipe length linear event, and then see and dynamically segment that back with my pipe in the utility network to get the characteristics. So we're modeling pipes as lengths, larger pipes as utility network objects, and then welds on top of that.
Okay, the next quick question is it compatible with the PPDM data model?
Absolutely. So we like to say that the utility network and the ArcGIS pipeline referencing are data model agnostic, right? So they don't need to be in a specific pipeline data model, but they do, however, need their set of feature classes configured in a way that are compatible with those tools. So we call those the core information model, right? They're the smaller pieces of the larger pipeline database that need to be implemented. And then obviously you would put the rule base on top of that as well. So you can build a utility network and an APR information model from scratch using the toolbox tools that we deliver with both products.
Great. Next question is that can we set rules with another layer, for example, pipe with electricity network, and how to do that?
Yep, absolutely. So one of the ways that the utility network is quite interesting is because we have the ability to have what we call domains. So I was demonstrating the pipeline domain, but multiple domains can exist in the same geodatabase. So you could have a water domain or an electric domain that has different rules and different components using that same cadence of connectivity, and then you can actually trace domains together. So for example, I can do an electric trace and tell me all the pumps that are going to fail if this electricity supply goes out, and then jump onto the pipeline and say, tell me all the pipes that are going to be impacted by these pumps that just failed because they no longer have electricity. So there's some really interesting cross-domain stuff we can do there as well.
Great. The next one is the how does asset spanning multiple MGA projection zone get handled?
Yeah, so the projections are typically handled through the core Esri projection engine. So most of the customers I work with were using some type of common projection system for the pipe data. Now we can store the geometry of the pipelines in unprojected geographic coordinates and have the measures in the linear references system and the pipe lengths be their true, metric measurement. So we can mix and match the two together. Most customers nowadays are going to storing their pipes as in lat long and having the measures be in a measured system.
Okay. Great. The next one is that when creating a point along a pipeline for linear referencing, is it considered also the terrain, elevations of pipeline underground? I think that you have covered that just now.
Yeah, so really what happens is the ability to take in the concept of terrain comes down to the pipe itself, right? So the pipe itself will have X, Y, and measure, but can also have X, Y, Z and measure, right? So if I want to introduce a terrain into that model as well, I could then, and I've actually done this where I've taken a utility network pipe and draped it on the terrain and then dropped it for 2 meters of cover. And then that's my elevation, and then I can put my pipe measures onto that as well. Obviously, all things being equal, if you had a very accurate as-built survey, the 3-dimensional lengths and your measured should be fairly equal. But because of historical reasons and different ways we measure pipelines, we really give you the ability to have Z and measure working independent.
Great, thank you. Did I miss any question, Jeff, Sarah?
Oh, it looks like I think we got them all.
Right.
Excellent. Great. Well, my contact information's on the slide, lies as well. Either one of us, please reach out to us if you have any follow-up questions you want to ask offline. A lot of questions, one maybe that didn't come up, but a lot of people ask is, how do I get started, right? So there's a lot of different ways, whether it be a proof of concept or a pilot project or different methodologies for getting started to build these networks up. But there's a lot of great information from Esri available on how to get started. And really, there's a lot of great knowledge sitting in the Esri distributor community and partner community in the APAC region. So we've got a lot of people that have utility network experience, linear referencing experience in the Asia Pacific region that can help you out with your specific requests. But we're from Esri Inc. We're always here to answer questions for you as well.
Great. So excellent. I think that's all the time that we have today. So if you have more questions, like Jeff mentioned, please reach out to us, and do reach out to your Esri contact in your respective country as well. So I hope that you find this webinar sharing useful and will benefit your great work in your organizations. All the best, and talk to you soon.
Thanks, everybody. Thanks for joining us today.
Thank you.